Let's go over the required work. There are three main design requirements that you need to practice and present in your work for any lab. First one is schematics, second one block diagrams, and the third flowcharts with no particular order. So let's go over a block diagram. A block diagram is an overview of your system. There is no specific symbols that you use for here, as long as it shows what you are trying to build. In this case, this example, it's a digital radio example. So here you have the antenna, then it goes over a radio frequency stage, and then an analog to digital converter, goes over your computer to do some filtering, and then over a digital to analog converter to go over the sound card. So notice that you don't have a lot of detail on this block diagram. It's just a bird's eye view, if you want to call it like that. But let's zoom in, let's go inside of the loudspeaker, and let's say that the loudspeaker is done using analog components like resistors, transistors, capacitors. In that case, you need a schematic. This one is fairly complex. If you took Intro to Mechatronic Systems 1, you are able to recognize transistors, you are able to recognize resistors, you are able to recognize capacitors, so capacitors, resistors, transistors, and obviously this is too complex for Intro to Mechatronic Systems 1 and 2 to understand. In reality, you're going to look something like along these lines, where you have a power supply, where you have switches, where you have resistors, and at the most some capacitors, again outside of the scope for this first year, but if you have, don't get scared, they're just filtering your system. It's possible to combine block diagrams with schematics, and notice on the symbols that I'm using here. So if for some reason you don't know how a particular part of your system works, you just do a block and you say that's a fundamental filter. And then later on you can fill with the respective electronics. Going back to our original block diagram, now let's zoom in inside of parts of the system that are done with a microprocessor or a computer. In that case, we have a bunch of code. In this case, this is an example done using Arduino, and we're going to use flowcharts. And the flowcharts are just representing the logic or the way that the code is being done. It's an abstract representation of your code. This one, to actually be correct, I'm missing that start symbol over here, and then it goes inside and it does the rest of the code. You don't need to get scared if you're taking Intro to Mechatronic Systems 2 without taking Intro to Mechatronic Systems 1. This was highly covered in Intro to Mechatronic Systems 1, but I can guarantee you that you will be doing good and learning throughout the quarter, and you will be doing block diagrams, schematics, and flowcharts very well by the end of the quarter.